Hello there guys, welcome back to another epic inexorable maths video. In this video, we're looking at something called the Weierstrass substitution. This is related to the T formulae, which I already have videos on, and I'll leave the link to the playlist and all of the separate videos in the description below so you can see them. But in this video, we're doing something a bit different. This is actually a more common thing than just the typical T formulae. This is the Weierstrass substitution, and it's used for doing integrals. So I've written all the T formulae there. We actually derived these in one of the videos, so I'm not going to explain why that they are true, because again, I have a video on it. But we actually have that sine x is equal to 2t over 1 plus t squared, cos x is 1 minus t squared over 1 plus t squared, and tan x is 2t over 1 minus t squared, where t is tan of x over 2. These can all be proved with the double angle formulae. You can use a triangle, you can use however you want. There's lots of ways to do it. They're not really that complicated to derive actually, they're quite simple. But what we're going to do now is we're not going to use them to solve trigonometric equations. We're going to use them for the very, very, very powerful and actually, dare I say, epic ability to turn the integral of a trig function into the integral of an algebraic function. So if you have an integral involving trigonometry, normally we're talking about fractions, something that looks a little bit like this. Then it won't always work, but sometimes you can turn it into an algebraic integral and then do that by doing what's called the Weierstrass substitution, named after a very famous and very good mathematician called Carl Weierstrass. So guys, how do we do it? This is how, okay? This is how. First thing I'm going to do is I'm going to show you guys that basically what you need to do is let t equal tan of x over 2, and then you can just use these identities. But I'm going to show you that when you replace dx with dt, the thing that comes along with it is always the same thing, okay? So the first step, this will make sense in a second, is to let t equal tan of x over 2. This says I'm using the T formulae, I'm using the Weierstrass substitution. Now, before we start replacing stuff, I just want to show you what dx is equal to in terms of dt, okay? So I'm going to work out what that is. So dt dx is going to be the derivative of tan x over 2 with respect to x. So that's going to be 1 over 2 times sec squared x over 2, because tan differentiates to sec squared, and then the 1/2 comes out because of the chain rule. Okay, and then we times both sides by dx, so dt is 1/2 sec squared x over 2 dx. And then we want to get dx on its own preferably, because then we can just always replace dx up here. So I'm going to try and make dx the subject. So dx is going to be dt divided by 1/2 sec squared x over 2. And this is fine, but really I would like this to all be in terms of t, because I'm turning the integral into terms of t. So preferably I want this in terms of t. How do I do that? Well, okay, first thing I'll do is I'm going to times the top and the bottom by 2 to get rid of this fraction here. So I'm going to have 2 dt over just sec squared on the bottom. But guys, remember that sec squared of anything is the same as 1 plus tan squared of that thing. That's an identity, that's a trig identity. So I'm going to replace sec squared of x over 2 with 1 plus tan squared of x over 2. But remember that t is tan of x over 2, so tan squared of x over 2 is just t squared. Okay, and I have this. And maybe it's a bit nicer to move the dt outside here. And voila, here's the thing that we do. So whenever you go from the trig integral into using the Weierstrass substitution, you're always going to want to replace dx with 2 over 1 plus t squared dt. That's the first thing that you're always going to want to do. I'm only going to do that in this video. In all future videos, that is just going to be a given, and I'm going to add it to our little toolbox here of stuff. So we also know that dx is equal to 2 over 1 plus t squared dt. That's now like a part of the things that we just know as facts. Okay, cool. Now we can get on with the actual question in this video. Cool. And actually, I didn't mean to rub that last bit off, but that's fine. Okay, so again, we're going to let t, we still need to write this, let t equal tan of x over 2. Then we replace dx with what it is down there, and we replace sin x with 2t over 1 plus t squared. So now the integral, and I'm going to call the integral capital I, so it's easier to refer back to it. Capital I is now the integral of 1 over 1 plus sin x is 2t over 1 plus t squared, and dx is 2 over 1 plus t squared dt. Hopefully that makes sense. Okay, now it might look more complicated, but we can simplify this. So just multiplying the numerators, we have 1 times 2, which is 2. And now multiplying the denominators, we'd have 1 times 1 plus t squared, so that's 1 plus t squared, times, plus 2t over 1 plus t squared times 1 plus t squared. That's just 2t, so plus 2t, and then dt on the end. And guys, already, don't you think that's quite cool? What we have done is we have turned an integral of trigonometry into an integral of just algebra. And in theory, this is easier. So we can do this. So how are we going to do this? Well, the first thing that I would do is I would factorize this. Maybe I would write the terms just a very slightly a different way around, just to make it a bit easier to see. I'm going to rewrite this as t squared plus 2t plus 1. So all I've done is move the order of the terms around. I've not done anything mathematically yet. Okay, now let's factorize the numerator, or sorry, the denominator. So t squared plus 2t plus 1, hopefully we can all agree that this is t plus 1 squared. Okay, now we can write this as the integral of 2 times t plus 1 to the power of minus 2 dt. Hopefully that also makes sense. And then guys, we can do a few different things. So we can use u substitution. We could let u equal t plus 1. Or we could use what I call the reverse chain rule, which is basically where we just look at it and we go, okay, well, I'm thinking that if this is already being differentiated and I'm trying to find what differentiates into this, which is basically what integration is, then I'm thinking that it would have to have been t plus 1 to the power of minus 1. Because if you differentiate this, you will get minus t plus 1 to the power of minus 2, which is actually what we've got here, but we don't have exactly that. We have 2 times t plus 1 to the minus 2, not minus t plus 1 to the minus 2. So does it make sense for me to say that minus 2 times all of this would have to differentiate to just positive 2 times that, okay? And basically, because this differentiates to this, this integrates to this, and that's it. So hopefully that makes sense. If what I just said there doesn't make sense, then that's absolutely fine, guys. Absolutely fine. Do it however you want, but hopefully the idea is we've turned it into a simpler integral. So again, this would be minus 2 times t plus 1 to the minus 1 plus c, okay? And just check that in your head. If you differentiate that, does it give you this? Well, yes, it does. And the last thing to do is, actually, I'll move on to the whiteboard below here. The last thing to do would obviously be to replace t with what it was. So remember that t was tan of x over 2. So basically the integral of 1 over 1 plus sine x, this was the original question with respect to x. This is equal to minus 2 over t plus 1. I'm going to do that. So minus 2 over t plus 1 plus c. But again, t is tan of x over 2. So I'm going to put it back into x. And t, that's actually just tan of x over 2. Okay, so the final thing is that the integral of 1 over 1 plus sine x with respect to x is minus 2 over tan of x over 2 plus 1. From there, if you want to simplify it even more, you absolutely can. You could use the double angle formula on tan and put it back in terms of just x if you want. Some people think it's a bit weird that when you do an integral of just a trig function of x, it becomes x over 2. It doesn't necessarily have to. You can just rewrite this in terms of x if you want, using, again, basically the t formula, the double angle formula here. And that's what you get, but that's the answer. So just so you can see all of the working out again, that's the other whiteboard. And yeah, hopefully that makes sense, guys. So as always, thank you so much for watching. Highly appreciate it. And I'll see you in the next video where we do some more Weierstrass substitution. Thanks for watching. I'll see you in the next one. Cheers.